What if the Big Bang wasn't the beginning? What if the Big Bang wasn't the beginning? What if our universe is just one of many, part of an endless cosmic reality? From infinite bubbles to quantum sparks, scientists have explored mind-blowing theories about multiple universes. Buckle up, because today, we're diving into 6 theories that could change everything we know about existence. Eternal inflation theory. Imagine this. Our universe, the one we see, the one we live in, is just a tiny bubble in an infinite cosmic ocean. Sounds crazy, right? But according to the eternal inflation theory, that's exactly what might be happening. Let's rewind to the Big Bang. The common belief is that it was a one-time event. Boom! The universe was born and here we are. But what if I told you the expansion that followed never actually stopped? Think of space like a loaf of bread that's rising in the oven. Our universe is just one of the countless air pockets trapped inside, and as the bread expands, more air pockets form. More universes, popping into existence all the time. This idea comes from cosmic inflation, a theory proposed by physicist Alan Guth. He suggested that right after the Big Bang, the universe expanded at an insane rate, faster than the speed of light. But here's the twist. Some parts of space may have stopped expanding, forming stable bubble universes like ours, while others kept stretching indefinitely. So what does that mean? It means the universe isn't just vast, it's endless. And within this ever-expanding space, an infinite number of bubble universes are forming all the time, each with its own physical laws. Some might be completely alien to us. Maybe gravity works backward, or stars never form at all. And here's the real kicker. If this theory is true, then somewhere out there could be an alternate version of you, living in a slightly different reality. Or maybe in another bubble universe, Earth never even formed. But here's the big question. If these other universes exist, can we ever reach them? Well, probably not. The distances between them are incomprehensibly vast, and the space between bubbles might still be expanding faster than the speed of light. So even if we could travel at insane speeds, we'd never catch up. Still, the idea is mind-blowing. The eternal inflation theory doesn't just suggest a multiverse, it suggests an infinite, never-ending creation of new universes. And who knows, maybe one day we'll find a way to prove it. But until then, we can only wonder, how many versions of reality are out there, beyond the reach of our imagination? Many worlds interpretation. Okay, let's play a game. Imagine you're standing at a crossroads, you can go left or right. Simple choice, right? But what if I told you that the universe doesn't just pick one path, it picks both? One version of you goes left, and another version of you goes right. Sounds insane? Well, welcome to the many worlds interpretation. This theory suggests that every time something happens, every tiny quantum decision, the universe splits. Not just once, but infinitely. It's like a cosmic choose-your-own-adventure book where every single possibility actually plays out in a different universe. This all starts with quantum mechanics, the weird, mind-bending science that governs the tiniest particles in existence. Scientists notice that particles don't behave the way we expect them to. Sometimes they exist in multiple states at once until someone observes them. But here's where things get wild. Instead of the universe choosing just one outcome, what if it creates a new universe for each possible outcome? Imagine flipping a coin. Heads, one universe, tails, another. But now scale that up. Every choice, every decision, every random event in history has led to a branch in reality. There could be a version of you that made a different career choice, moved to a different city, or never even existed at all. It also means history itself is a tangled mess of infinite possibilities. In one universe, the dinosaurs never went extinct. In another, humanity colonized Mars centuries ago. In yet another, the laws of physics might be completely different, making life impossible. But here's the real kicker. We can't communicate with these other versions of reality. Once a new universe is formed, it becomes completely independent. That means there could be billions of versions of you out there, making different choices, but you'd never know it. So, if the many worlds interpretation is correct, reality isn't just one timeline, it's an infinite sea of timelines, each playing out every possible scenario. And the craziest part, this isn't science fiction. Some of the greatest physicists on Earth take this theory very seriously. Cyclic model. What if I told you the universe didn't just have one beginning, but an infinite number of them? What if the Big Bang wasn't the first explosion of creation, but just one of many? Welcome to the cyclic model. A theory that completely changes the way we think about time, space, and existence itself. For most of us, the story of the universe is simple. The Big Bang happened, everything expanded, and eventually, it'll all either drift apart forever or collapse into nothing. But the cyclic model says, nope, that's not how it works. Instead, the universe goes through endless cycles of birth, death, and rebirth, forever. Imagine a giant cosmic heartbeat. The universe expands, galaxies form, stars are born, life emerges, but eventually the expansion slows down. Gravity pulls everything back together. Over billions of years, everything collapses into a single, dense point, just like before the Big Bang. Then, boom! Another Big Bang, a new universe, a new cycle. This has been happening for eternity. This means our universe is not the first, and it won't be the last. There could have been trillions of universes before this one, each with different histories, different possibilities, maybe even different laws of physics. And after our universe reaches its end, another one will rise in its place. One of the most mind-blowing parts of this theory? If the cyclic model is true, then the Big Bang wasn't really the beginning of time. It was just the latest reboot. The ultimate cosmic reset button. But here's the big question. If we're living in an endless loop, could something, anything, survive from one universe to the next? Could the fundamental structure of the cosmos carry over? Or crazier still, could memories, information, or even versions of us somehow persist across cycles? Right now, we don't have all the answers. But one thing is clear. If the universe has been cycling for eternity, then the past, present, and future are just different chapters in a never-ending story. A story that keeps rewriting itself. And if that's true, then the universe you know isn't just part of history. It's part of infinity. Brain cosmology. What if I told you that our universe isn't the only one, but just a tiny slice of a much bigger reality? What if everything we see, from galaxies to black holes to ourselves, is trapped inside a giant, invisible cosmic membrane, floating in a higher dimensional space? Sounds like science fiction, right? But this is exactly what brain cosmology suggests. Imagine a piece of paper, that's our universe, a thin, flat sheet floating in space. Now imagine another piece of paper, parallel to ours but completely separate. That's another universe, and there might not just be two, there could be millions of them, all stacked like pages in an infinite cosmic book. But here's the mind-blowing part, these brains don't just sit there, they move. Brain cosmology, which comes from string theory, suggests that these invisible, higher-dimensional membranes can collide, and when they do, boom, a new Big Bang. That's right, our entire universe may have been born from two massive brains slamming into each other in a higher dimensional space. Think about what this means. It suggests that Big Bangs aren't one-time events, they happen over and over, every time brains collide. And if this is true, it means other universes, completely separate from ours, are forming all the time. Some might have entirely different physics, where gravity is weaker, or light moves slower, or time flows in reverse. But here's where it gets really crazy. If our universe is just a three-dimensional brain inside a higher dimensional space, then what else is out there? Could there be beings, civilizations, or even entire realities in dimensions we can't perceive? Could gravity, which seems weaker than the other forces, actually be leaking into these other universes? And if brains collide to create Big Bangs, could they also interact in other ways? Could there be signs of other universes pressing up against ours, influencing it in ways we haven't yet detected? Some scientists think the strange anomalies in the cosmic microwave background, leftover radiation from the Big Bang, might actually be the fingerprints of another universe brushing against our own. So, if brain cosmology is right, then our universe isn't all there is. We're just one floating membrane in an endless cosmic ocean. And somewhere out there, beyond what we can see, the next great collision might already be on its way, bringing another universe to life. Quantum fluctuation model. Alright, get ready for this. What if the entire universe, everything you see, everything you know, just popped into existence out of nowhere? No grand design, no cosmic blueprint, just a tiny random fluctuation in the fabric of reality that suddenly blew up into the universe we live in today. Sounds ridiculous, right? But according to the quantum fluctuation model, that's exactly what might have happened. To understand this, we need to dive into the bizarre world of quantum mechanics, where particles appear and disappear in empty space, as if reality itself is flickering in and out of existence. This isn't science fiction, it's a proven fact. In the quantum realm, energy randomly fluctuates, creating tiny bursts of matter that exist for fractions of a second before vanishing. But what if, once upon a time, one of these fluctuations didn't vanish? What if instead it grew? Some physicists believe that the universe itself could have emerged from one of these quantum blips, starting as an incredibly tiny speck of energy, which then rapidly expanded into everything we see today. In other words, the Big Bang might not have been a singular planned event, but just the result of a random natural process. But here's where it gets even wilder. If our universe was born from a quantum fluctuation, why stop at one? If this is a natural process, then universes could be forming all the time. In the vast emptiness beyond what we can observe, new Big Bangs might be sparking into existence, creating entire new realities with their own stars, galaxies, and maybe even life. And what if this cycle never ends? In some versions of this theory, even when our universe eventually fades away, another quantum fluctuation could create a brand new one, restarting the process all over again. It's like the cosmos is a never-ending quantum lottery, constantly spitting out new universes, some successful, some not. So if this theory is correct, then our universe is nothing special. It's just one of countless others, each born from the strange and unpredictable laws of quantum physics. Which raises an even bigger question. If universes can pop into existence from nothing, then what's stopping another one from forming right now, right in front of us? Pre-Big Bang scenario. We all know the story. The universe began with the Big Bang, an explosion of energy and matter that created everything we see today. But here's the real question. What happened before the Big Bang? Was there nothing? Just an empty void waiting for reality to begin? Or was something already there, something far older than our universe itself? Welcome to the mind-bending mystery of the pre-Big Bang scenario. For a long time, scientists avoided this question entirely. The Big Bang was considered the beginning of time itself, so asking what came before it was like asking what's north of the North Pole. But now, some theories suggest that the Big Bang wasn't the first event. It was just a transition, a transformation of something that already existed. One possibility? Our universe was born from the collapse of a previous one. Imagine a universe that expanded for billions of years, just like ours is now. But instead of stretching forever, it eventually slowed down, reversed, and crunched into a single, ultra-dense point. That moment, the Big Crunch, then triggered a new Big Bang, rebooting the universe in an endless cycle of expansion and collapse. Another theory suggests that the Big Bang was actually the result of two higher-dimensional universes, also known as branes, colliding in a vast, unseen dimension. The energy released in this cosmic smash-up could have sparked the birth of our universe, meaning there could be an entire history of universes before ours, stretching back indefinitely. But here's where it gets really wild. What if the pre-Big Bang universe wasn't like ours at all? What if it had different laws of physics, different dimensions, or even a completely different form of matter and energy? If that's the case, then our universe isn't just young, it's part of an unimaginably ancient chain of realities, each one shaping the next. And maybe, just maybe, clues about this forgotten era still exist. Some scientists believe that remnants of the pre-Big Bang universe could be hiding in the cosmic microwave background, the faint glow left over from the Big Bang. If we can decode these signals, we might finally uncover the truth about what existed before everything we know. So, was the Big Bang really the beginning? Or was it just the latest chapter in a story far older than we can possibly imagine? The universe may never give up all its secret, but that won't stop us from trying to find out. The universe is full of mysteries, and the idea of multiple realities is just the beginning. Which theory blew your mind the most? Let me know in the comments. And if you love exploring the unknown, don't forget to like, subscribe, and hit the bell for more mind-bending content, only on InnoVision Tech. Have you ever wondered if life once thrived or still exists on Mars? From ancient oceans and microbial fossils to mysterious methane bursts, Mars has fueled some of the most fascinating theories about extraterrestrial life. What if our neighboring red planet holds the answers to questions about the origin of life itself? Join us as we explore 7 mind-blowing theories about life on Mars that could completely reshape how we see the universe. Martian microbial life in the ancient past. Mars wasn't always the cold and barren desert we see today. Billions of years ago, the planet had an entirely different environment, one that might have been perfect for supporting microbial life. Scientists believe that during its early history, Mars had flowing rivers, lakes, and even large oceans, along with a much thicker atmosphere that could have created stable conditions for life to thrive. One of the most fascinating clues comes from the discovery of ancient riverbeds, deltas, and mineral deposits scattered across the Martian surface. These features point to a time when liquid water was abundant on the planet, and where there's water, there's a possibility for life. On Mars, these wet environments may have been home to microbial colonies. NASA's Curiosity rover even found organic molecules in Martian soil, which could have formed in the presence of ancient life. While they aren't definitive evidence, they make a compelling case for further exploration, especially when you look at extremophiles on Earth, microorganisms that thrive in harsh environments. From boiling hot springs to deep-sea hydrothermal vents, life on Earth has proven incredibly resilient, suggesting that if microbes could survive such extreme conditions here, similar life forms could have adapted to Mars. Early Mars likely had geothermal heat and volcanic activity, providing energy sources that could have fueled life in much the same way. Future missions like Perseverance and ExoMars are designed to dig deeper into this question by studying ancient Martian rocks and drilling into the planet's surface, searching for biosignatures, chemical or structural markers that indicate the presence of past life. If evidence of ancient microbes is ever found, it would reshape how we understand the origins of life, not just on Mars but across the universe. Mars might not just be a neighbor in space, it could be a key to answering one of humanity's oldest questions: are we alone? Methane mysteries and living organisms. Mars has been keeping us on the edge of our seats with its methane mystery. For years, scientists have detected fluctuating levels of methane gas in the Martian atmosphere, raising the question of its origin, especially since on Earth, methane is often linked to biological activity produced by living organisms like microbes or larger creatures. When methane spikes were recorded on Mars, it sparked an exciting debate about the possibility of life on the red planet. What makes this discovery so intriguing is how methane behaves, as it doesn't last long in an atmosphere like Mars's because sunlight and chemical reactions break it down relatively quickly, meaning if it's being detected, something must be actively producing it. Scientists believe there are two possibilities. It could be a geological process like serpentinization, where certain types of rocks interact with water and heat to release methane, or it could be biological, hinting at microbial life living beneath the surface. What's fascinating is how both explanations are equally plausible, given that Mars has evidence of underground reservoirs where water might still exist in liquid form, providing perfect conditions for methane-producing microbes to survive. On Earth, similar microbes thrive in extreme conditions, like deep underground or at the bottom of the ocean, without needing sunlight, suggesting that if similar life exists on Mars, it might be tucked away in subsurface environments, safe from the planet's harsh surface conditions. The European Space Agency's Trace Gas Orbiter and NASA's Perseverance rover are actively investigating these methane spikes, trying to trace their origin. The hope is that further data will reveal whether Mars's methane has a geological or biological source. If methane is linked to life, it could mean Mars isn't just a relic of the past, it could be harboring life even now. And even if it's geological, it tells us Mars is more dynamic than we ever imagined, with the answers out there and every new clue bringing us closer to unraveling the story. Water beneath the surface. Mars has always fascinated us, especially regarding water, as evidence suggests liquid water might still exist beneath its barren surface. This discovery could be a game-changer, not just for understanding Mars's history, but for the possibility of current life, as subsurface water reservoirs could hold the key to the planet's greatest secrets. In 2018, researchers using data from ESA's Mars Express orbiter detected a massive lake of liquid water buried beneath the South Polar ice cap, stretching about 12 miles across. The water is incredibly salty due to minerals that lower its freezing point, allowing it to stay liquid despite freezing temperatures, an environment similar to Earth's hypersaline lakes that support microbial life. The search hasn't stopped there, with radar signals suggesting additional water pockets near the original discovery. These findings suggest underground aquifers might spread across Mars, with some being relics from its wetter past, while others might be sustained by geothermal heat. What makes this thrilling is the potential for these reservoirs to support life, as even in Earth's harshest places, like Antarctica or the Dead Sea, microbial life thrives in salty, isolated waters. Mars might have similar conditions underground, where life could exist safely away from radiation. Future missions like ESA's ExoMars or NASA's Perseverance rover aim to investigate further. Each discovery brings us closer to understanding whether Mars is not just a world of ancient mysteries, but a planet harboring current life beneath its surface. Beneath its dusty exterior, Mars might hide the greatest scientific discovery, active water and possibly life itself. The red planet continues to surprise us, suggesting its most fascinating secrets lie not on its surface but deep within. Martian meteorites, seeds of life. Martian meteorites hold fascinating clues about life on Mars, as these pieces of the red planet, ejected by massive asteroid impacts, eventually made their way to Earth and contain hints suggesting Mars may have once hosted life. These cosmic messengers offer a unique glimpse into Mars's ancient past, with dozens found scattered across our planet. One famous example is ALH 84001, discovered in Antarctica in 1984, containing tiny structures that some scientists believe resemble fossilized microbial life, along with organic compounds and magnetite crystals that sparked intense debate about their origin. While the question of whether these features are biological remains unresolved, ALH 84001 transformed our perspective on Mars and life in the cosmos. What's even more intriguing is that these meteorites often contain organic molecules and amino acids, the building blocks of life, suggesting Mars may have had conditions suitable for life to emerge. Scientists are particularly fascinated by isotopic ratios within the meteorites, which indicate water interaction and chemical reactions that could support life, aligning with other evidence of ancient water on Mars. The implications extend beyond the meteorites themselves, as some researchers propose that Earth and Mars may have exchanged biological material through meteorite impacts in the distant past. If microbial life existed on Mars, these meteorites might have acted as seeds, spreading organisms between planets. This interconnection of our solar system raises profound questions about life's origins and distribution. Each meteorite analysis provides new insights into Mars's potential for harboring life. As we continue studying these cosmic travelers, they may reveal not only Mars's secrets but also clues about life's origins in the universe. These space rocks serve as bridges between worlds, connecting Earth's present to Mars's mysterious past. The panspermia hypothesis. Mars as a life seed. The panspermia hypothesis suggests that life might not have originated on Earth but was seeded here by microbial life traveling through space, with Mars often taking center stage as scientists speculate that Earth's life might have come from Martian meteorites. This idea fundamentally challenges our understanding of life's origins and suggests Earth and Mars share a deeper connection than previously thought. Mars stands as a strong candidate for being a life-seeding planet because billions of years ago, it may have been much more Earth-like, with flowing water, a thicker atmosphere, and life-supporting temperatures. During that early period when meteorite impacts were frequent in the solar system, powerful asteroid strikes on Mars could have ejected rocks containing microbial life into space, potentially reaching Earth over thousands or millions of years. The discovery of Martian meteorites on Earth proves such material transfer is possible, lending credibility to the theory. What makes this hypothesis particularly compelling is the remarkable resilience of certain microorganisms, as some bacteria and archaea can survive extreme conditions from freezing temperatures to the vacuum of space. If microbes could endure interplanetary travel, it suggests life might spread throughout the cosmos rather than arising independently in isolated locations. Mars might have acted as a starter planet, where early microbial life developed before being transported to Earth through cosmic debris. The implications of panspermia push us to reconsider life's boundaries and origins, suggesting that Earth's earliest organisms might have been part of a larger interplanetary system. This raises intriguing possibilities about life existing elsewhere in our solar system, potentially seeded from Mars or Earth. The panspermia hypothesis reframes life's story as a cosmic narrative that spans multiple worlds. These connections between planets suggest that understanding life's origins requires us to look beyond Earth and consider the complex interactions between celestial bodies over billions of years. Subsurface life in hydrothermal systems. Mars holds many mysteries, but one of the most exciting is the possibility of life beneath its surface, particularly in ancient hydrothermal systems where planetary heat interacts with water, environments that teem with extremophile organisms on Earth. Billions of years ago, Mars was radically different, with liquid water, volcanic activity, and a thick atmosphere that would have naturally created hydrothermal systems. When water seeped below the surface, it could have interacted with magma or other heat sources, creating perfect conditions for microbial life to emerge and potentially persist for millions or billions of years after the surface became inhospitable. Just as Earth's extremophiles thrive in hydrothermal vents and subglacial hot springs by living off chemical energy rather than sunlight, Martian life could have adapted to survive underground, feeding on minerals and compounds produced by hydrothermal activity. The discovery of methane and other gases on Mars hints at the possibility of ongoing microbial life in these subsurface environments, protected from the harsh surface conditions. Both NASA's Perseverance rover and ESA's ExoMars mission are investigating these possibilities, analyzing Martian rocks and soil for evidence of hydrothermal activity and potential biosignatures. Understanding Mars's hydrothermal history is crucial because these systems could have provided long-term habitable environments even as the planet's surface changed dramatically. If we find evidence of past or present life in these environments, it would revolutionize our understanding of habitability in the universe. The search for life in Mars's hydrothermal systems represents a convergence of geology, chemistry, and biology. These underground environments might have preserved conditions suitable for life long after Mars's surface became inhospitable. The study of Martian hydrothermal systems could reveal not just the planet's history, but also provide insights into how life might persist in extreme environments throughout the cosmos. Ancient oceans and Mars's lost atmosphere. Mars was once a world of water, where vast oceans covered parts of the planet's surface, as evidenced by dried-up river valleys, ancient shorelines, and water-formed minerals discovered by orbiters and rovers. These findings reveal Mars had a warmer, wetter climate capable of supporting large bodies of liquid water, making these ancient oceans prime candidates for the potential origin of Martian life. While some of Mars's water remains locked in polar ice caps or hidden underground, a significant amount has vanished into space, tied to the planet's atmospheric history. Long ago, Mars had a much thicker atmosphere rich in carbon dioxide, creating a greenhouse effect that trapped heat and allowed water to exist in liquid form. The loss of this atmosphere is believed to be caused by Mars's weak magnetic field, as unlike Earth, Mars lacks global magnetic shielding from the sun's powerful solar wind. Over billions of years, this solar wind stripped away the Martian atmosphere, leaving it thin and unable to retain heat, causing the planet's surface water to either freeze or evaporate into space. NASA's MAVEN spacecraft continues studying this atmospheric loss process, helping scientists reconstruct ancient Mars and assess whether its oceans could have supported microbial life. The existence of an ocean as vast as Earth's Arctic Ocean makes the possibility of past Martian life more compelling. Understanding the relationship between Mars's lost atmosphere and ancient oceans provides crucial insights into planetary evolution and habitability. Scientists are particularly intrigued by evidence suggesting these oceans persisted for hundreds of millions of years. The transformation from a water-rich world to today's desert planet serves as a stark reminder of how planetary conditions can change dramatically over time. Mars's ancient oceans tell a story of a planet that might have once been remarkably similar to early Earth, raising intriguing questions about life beyond our planet. And that wraps up our deep dive into 7 theories about life on Mars that could very well be true. Whether it's hidden microbes, ancient oceans, or Martian meteorites, the Red Planet continues to hold some of the universe's greatest secrets. If you enjoyed this cosmic exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep reaching for the stars with us. Imagine a gateway that bends space and time, a cosmic shortcut to distant galaxies or even parallel universes. Black holes and wormholes, 2 of the universe's most mind-bending mysteries, might just be the key. Could they be hidden doorways to the unknown? Let's dive into the science behind these cosmic enigmas. What are black holes? Black holes are cosmic monsters, regions in space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse under their own gravity, creating a point of infinite density called a singularity. Around this singularity is the event horizon, the boundary beyond which escape is impossible. Anything that crosses this threshold is lost forever, trapped in a one-way journey to the unknown. Scientists believe black holes warp space-time itself, bending light and altering time in ways that defy common sense. Some black holes are small, formed from dying stars, while others, supermassive black holes, lurk at the centers of galaxies, including our Milky Way. The mind-bending part? According to Einstein's general relativity, time slows down near a black hole. If you could somehow hover near one, you'd see the outside universe speed up, while to an outside observer, you'd appear frozen in time. A black hole isn't just an object, it's a tear in reality itself. Black holes are born in the violent deaths of massive stars. When a star much larger than our sun reaches the end of its life, it undergoes a supernova explosion, shedding its outer layers in a massive burst of energy. What remains collapses inward, crushed under its own gravity until it forms a singularity, a point of infinite density. The surrounding space becomes so warped that not even light can escape. The size of the resulting black hole depends on the original star. Stellar black holes are a few times the mass of our sun, while supermassive black holes, millions or even billions of times larger, sit at the hearts of galaxies, feeding on matter and merging with others over billions of years. Some theories suggest that primordial black holes, much smaller and possibly created in the early universe, might still be lurking undetected. Whether born from dying stars or cosmic chaos, black holes are nature's most extreme laboratories, testing the limits of physics itself. What happens if you fall into a black hole? Falling into a black hole would be the most terrifying and mind-bending experience imaginable. As you approach, gravity gets stronger, pulling you faster and faster toward the event horizon, the point of no return. From the outside, an observer would see you slow down, appearing frozen in time as you near the edge. But for you, time would seem normal, but space itself would stretch in bizarre ways. This is called spaghettification, where the gravity at your feet is stronger than at your head, stretching your body into a long, thin strand like spaghetti. Eventually, you'd be torn apart at the atomic level. But what happens next? If black holes truly lead to singularities, your matter would be crushed into an infinitely small point. However, some theories suggest something more mysterious. You could emerge in another universe or be funneled through a wormhole. And if black holes somehow connect to white holes, objects that can only expel matter, then maybe falling in isn't the end, but a new beginning somewhere else. No one knows for sure, but one thing is certain. Crossing the event horizon is a one-way trip into the unknown. Could black holes be the key to time travel? Some physicists believe so. According to Einstein's general relativity, massive objects warp space-time, and since black holes are the most extreme warps in existence, they could theoretically alter the flow of time. Near a black hole, time slows down drastically compared to the outside universe. If you could orbit close enough without falling in, you could experience time at a much slower rate than people back on Earth. In theory, this means you could travel to the future, a kind of time dilation that could let astronauts return after what felt like a few years to them, while centuries passed on Earth. But what about traveling to the past? That's where wormholes come in, hypothetical tunnels through space-time that might allow shortcuts between different points in time. Some theories suggest that black holes could actually be entrances to wormholes, but there's a catch. Keeping them open requires exotic matter with negative energy, something we've never observed in nature. Could advanced alien civilizations have figured out a way to stabilize them? If so, black holes might not just be destructive voids but hidden doorways through time itself. What are wormholes? Imagine a tunnel through space and time, a shortcut that lets you travel light years in an instant. That's the concept of a wormhole, a theoretical bridge connecting two distant points in space-time. First proposed in Einstein's general relativity, wormholes are sometimes called Einstein-Rosen bridges and are often depicted in sci-fi as portals that make interstellar travel possible. Unlike black holes, which are one-way traps, wormholes could act as two-way doors, allowing matter and even spacecraft to pass through. But here's the catch. If wormholes do exist, they are likely unstable. The moment something enters, it might collapse instantly, making travel impossible. Scientists believe that to keep a wormhole open it would require exotic matter, a form of energy that defies the laws of physics as we know them. Some theories even suggest that wormholes could connect parallel universes or different points in time, making them potential gateways not just across space but across dimensions. If we could ever stabilize one, it would revolutionize space travel forever. But do they really exist? That's where things get complicated. Are wormholes real or just theoretical? Right now, wormholes exist only in equations, not in reality. Scientists have never observed one, but the math behind them checks out. According to Einstein's general relativity, space-time can bend and fold, meaning wormholes could be possible under the right conditions. In fact, some physicists believe that tiny wormholes might appear at the quantum level, constantly forming and vanishing within the fabric of reality. These are called quantum foam wormholes, but they are far too small for us to use. The biggest problem? Stability. Normal matter cannot hold a wormhole open, it would collapse instantly. The only way to stabilize one is through negative energy or exotic matter, something we have never found in nature. However, some advanced theoretical models suggest that naturally occurring wormholes might exist inside black holes, or even at the center of galaxies. If that's true, then maybe the universe already has built-in shortcuts, waiting to be discovered. Until we find solid proof, wormholes remain an exciting but unproven possibility, one that could change everything we know about space and time. Black holes and wormholes might sound similar, but they are completely different cosmic phenomena. A black hole is like a cosmic trap. It pulls everything in, including light, with no escape. It's formed from the collapse of a massive star, creating a region of infinite density known as a singularity. Once you cross its event horizon, you're doomed to be crushed by gravity. A wormhole, on the other hand, isn't a trap, it's a potential shortcut through space and time. Instead of pulling things in and crushing them, a wormhole, if stable, could allow matter to pass through and emerge somewhere else, possibly even in another galaxy or universe. The problem? Black holes definitely exist. We've observed them in space. But wormholes? They remain purely theoretical. Another key difference is stability. Black holes last for billions of years, but wormholes, if they exist, might collapse instantly without exotic matter to hold them open. While black holes are real and terrifying, wormholes are like a dream, one that, if proven, could change space travel forever. Could wormholes connect different universes? One of the most mind-blowing theories in modern physics suggests that wormholes might be more than just shortcuts within our universe. They could be bridges to other universes entirely. This idea is linked to the multiverse theory, which proposes that our universe is just one of many. If wormholes exist, they might not just link distant points in space but act as portals between parallel realities. Some scientists even theorize that black holes could be entrances to such wormholes. If matter falls into a black hole, instead of being crushed into a singularity, it might be transported through a wormhole and emerge in an entirely different universe, possibly as a white hole, a hypothetical object that can only expel matter. This could explain where all the lost matter inside black holes actually goes. The challenge? We have no way to test this idea yet, but if we ever find evidence that wormholes connect universes, it could mean that reality is far bigger than we ever imagined, with countless parallel worlds just a wormhole away. In theory, wormhole travel could be the ultimate breakthrough in space exploration, allowing us to bypass the limitations of light-speed travel and reach distant galaxies instantly. But the problem is, no one knows if a traversable wormhole can actually exist. Even if they do, they would likely collapse the moment anything enters them, making safe passage impossible. The key to keeping a wormhole open lies in exotic matter, a form of energy with negative mass that could counteract the wormhole's natural instability. However, exotic matter has never been observed in nature, making the whole idea purely theoretical. Another issue is where a wormhole might take you. Unlike a road with clear signs, wormholes could lead to unpredictable locations or even different time periods. Some physicists believe that an advanced alien civilization, if they exist, might have already figured out how to stabilize wormholes for travel. If we ever develop the technology to manipulate space-time, humanity could one day use wormholes as cosmic highways, revolutionizing how we explore the universe. But for now, traveling through a wormhole remains a fascinating yet unsolved mystery. What if black holes and wormholes are linked? Could black holes actually be hidden wormholes in disguise? Some scientists believe so. The idea comes from the fact that black holes warp space-time to such an extreme degree that they might actually be tunnels leading somewhere else. Instead of being a one-way trip to destruction, a black hole could function as the entrance to a wormhole, transporting anything that falls inside to another part of the universe, or even a different universe altogether. One of the most intriguing possibilities is that the matter falling into a black hole doesn't just disappear, it could be expelled through a white hole, the theoretical opposite of a black hole. Unlike black holes, white holes don't allow anything to enter them, only to exit. This raises the possibility that black holes and white holes are two ends of the same wormhole. However, no white holes have ever been observed, and the energy needed to create a stable black hole wormhole connection is beyond anything we can currently comprehend. If black holes really do connect to wormholes, it would mean that they're not just cosmic traps but hidden gateways waiting to be unlocked. Black holes and wormholes represent the greatest mysteries of the cosmos, one a trap, the other a potential gateway. While black holes are real and terrifying, wormholes remain hypothetical, but if we can ever harness their power, they could redefine how we explore the universe. Imagine a future where spaceships no longer take centuries to reach distant stars, but instead travel through cosmic shortcuts, arriving in seconds. The biggest challenge? Science and technology aren't there yet. We don't know how to create, stabilize, or navigate wormholes, but with advancements in quantum physics and AI, what seems impossible today might become reality in the future. Perhaps the universe is already filled with natural wormholes waiting to be discovered. If we ever find one and figure out how to use it, the age of interstellar travel won't just be science fiction. So, what do you think? Could we travel through one in the future? Let me know in the comments. And if you love mind-blowing space theories, don't forget to subscribe to InnoVision Tech, hit the like button, and turn on the notification bell so you never miss an adventure.